Alright, now we're on to problem 31. 31 is a simple distributing property problem. Okay, distribute 2x to both terms. You get 6x squared plus 12x. Distribute negative 5 to both of the other terms. You get negative 15x minus 30. We identify like terms. Nobody is alike with the 6x squared. Here are two x terms. That's negative 3x when we combine them. And lastly, we have a constant term, which is negative 30. And that's it. We can't combine any of those because they are not alike. 32, we'll put a big asterisk by it because a lot of people mess this one up. It's the same as 31, except we have to use the definition of squaring, which means multiply whatever is being squared by itself, which makes this a big FOIL problem. Again, we distribute the 4x, 16x squared minus 12x. We distribute the negative 3, which gives us negative 12x again, plus negative 3 times negative 3, positive 9, giving us a final result here of 16x squared, negative 24x plus 9. Factoring problems, we just had a test with factoring, so if you haven't gotten it yet, you're a little late. Okay, the 9x squared is the first term times the first term. The 1, let's put it in purple here, is a result of the product of the last term in each binomial. And then finally the tough part is that 6x in the middle, that comes from this product and this product, and since both of those products are 3x, and we want a positive 3x in the middle, those better be positive 3x's. Okay, we'd probably write this in shortcut form. That's the same as 3x plus 1 quantity squared. 34 here. Step 1, always look for a GCF. The previous problem didn't have one, but there is one here. Okay, if you check it, distributing the 2, you get 18x squared minus 2, which is our starting point. That 9x squared minus 1, that is a difference of two squares, which you should be familiar with. It's 3x minus 1, 3x plus 1. Note there is no middle term in that, and this factorization actually yields no middle term because this first is a negative 3x, the outside is positive 3x, and that's why we don't see a middle term as a result of that factorization that we've used. Alright, moving on to 35. Let's get that pulled up here. Okay, problem number 35, we're supposed to solve these. That one's already factored. So if 2x minus 3 times 3x plus 1 equals 0, one of those factors has to equal 0. That is called the zero product property. Okay, that's what we're using to solve that. And so x is 3/2, or subtract 1, x is negative 1/3. So it's quadratic, and we end up with two solutions. Next one, also quadratic, but this one's a special quadratic. There is no linear term, which means we can solve by square rooting both sides. Remember, you get plus or minus 5. We always get plus or minus when we solve by square rooting both sides. And 37, x squared minus 5x minus 2 equals 0. Remember, get it equal to 0 if it's got all three terms. And this one does not factor. Since I recognize it doesn't factor, we run to the quadratic formula, because the quad formula works every single time. Here it is. I noticed on our test a few people didn't have it memorized. Well, without it being memorized, you just can't use it. Okay, we want the opposite of b, so it's 5. Square root of, we take our b value and square it. Negative 5 squared is 25. Minus 4 times a times c all over, and 2a is 2 times 1. So doing the math underneath the radical, that's the discriminant, I get a discriminant of 25. This double negative makes it plus 8. That's 33 all over 2. 33 is 3 times 11, both prime, so it doesn't break down, and I'm done. Notice it's all over that denominator of 2. Alright, next on to problem number 38, I believe it was. Let's do 38 and 39. Okay. That. 38, let's find the vertex of this quadratic. To find the vertex, I'd use the little equation, negative b over 2a. We go opposite of negative 4 is 4, over 2 times 1. 4 over 2 is 2. There's the x-coordinate of the vertex. Plug that 2 in, and it will tell you what the y-coordinate is. So that's 4 minus 8 minus 3, being negative 4 minus 3, negative 7. So this vertex is at 2, negative 7. Axis of symmetry, x equals 2, if they ask that. Dimensions of a matrix is always row by column. This has 1, 2, 3 rows. It's got 2 columns, so this is a 3 by 2 matrix. And last in this group, number 40. Oops, we also have, yeah, there it is, number 40. 40, find the determinant. To find the determinant, I'll just remind you of how we do that. A, B, C, D. The determinant is AD minus BC. So for us, it's 4 times 3 minus 1 times 2, 12 minus 2. The determinant is 10. Let's see if we can go ahead and finish this review guide out in this video. Find the inverse of the matrix in question 40. I'm going to write that matrix down. 4, 2, 1, 3. I want the inverse of that. Our calculator, if you remember how to do it on your calculator, you can use that. To find the inverse, I'm going to use 1 over the determinant. My determinant was 10, so 1 over the determinant times, and then remember we flip-flop that main diagonal, change the signs in the other diagonal, and so our inverse is 3/10 when I multiply, negative 2/10, which is negative 1/5, negative 1/10, and 4/10, which is 2/5. So there is my inverse matrix. 42 I will run through in class, but I will set it up for you. We set up our coefficient matrix by writing down all of our coefficients. 6, negative 4, negative 5. Our variable matrix, x, y, z, and our constant matrix, 8, 4, 12. And I certainly would use matrices to solve that, but you can solve it by elimination if you forget how to use your calculator. Problem 43. Let's pull that up. Problem 43, solve for y, so we get all of our y's together. 3y minus 8xy equals, I'm going to take that 4x to the other side, so it's positive 4x minus 2. Now I've got y's in 2 spots, so we're going to factor that y out. And I get 3 minus 8x equals 4x minus 2. And therefore y is 4x minus 2 divided by the quantity 3 minus 8x. With the restriction, and to get our restriction, just set your denominator equal to 0. Solve that for x, negative 3, and we find out 3/8 makes it 0, so we say x cannot be 3/8. Domain and range, this is a parabola that you can graph on your calculator pretty quick, and you'll see it starts at negative 5 and opens up. Domain goes left and right forever. Range, y values are greater than or equal to 5. And what is the maximum value of this function? Getting a little worn out of doing some of these problems, but we go find our x coordinate of our vertex. Let's do this the other way. It'll kind of make it more fun. Let's complete the square on it by factoring out a -2. Okay, so that's the same equation, just with the -2 factored out of the quadratic and linear term. Then remember, we take b, the 2, we divide it by 2, and we square it. 2 divided by 2 is 1, 1 squared is 1. And we've actually added a -2, so we add a +2 to the outside. It is now our perfect square, and our vertex is at -1, 3, but our maximum, and some people were giving me the vertex, is 3. And that's it for the review guide.